Hello everyone. In this video, we are going to learn about shortest job first scheduling, like also known as SJF scheduling in operating system. Okay. So here is definition. SJF stands for shortest job first. So in this scheduling, the process with the smallest burst time is selected next for execution. It reduces the average waiting time compared to FCFS. Type is SJF can be of two types. Non-preemptive SJF. Once a process starts, it cannot be interrupted until it finishes. Then preemptive SJF, also called shortest remaining time first. If a new process arrives with the shorter burst time than the currently running process, the CPU is given to the new one. Okay, see. So it is very simple. In this scheduling, the process which has the smallest burst time, or in other words, the shortest execution time, is selected for execution first. Okay, so that's why it is called shortest job first. Okay, so this algorithm is better than FCFS because it helps in reducing the average waiting time. Okay, and SJF can work in two ways. First one is non-preemptive, means once a process starts, it runs until it finishes. Then preemptive, also called shortest remaining time first, like where if a new process arrives with a smaller burst time, it interrupts the current process. Okay, basically, see, imagine you are at a hospital and patients are waiting for treatment. Okay, and the doctor has to decide who to treat first. If the doctor follows the first come first serve rule, then the first patient who arrive will be treated first. So no matter how long the treatment takes. But what if the first patient's treatment will take 3 hours and the next patient only needs 10 minutes? If the doctor sticks to FCFS, then the 10-minute patient has to unnecessarily wait for 3 hours. Okay, so basically this increases the waiting time for small tasks. So basically this is exactly where shortest job first comes in. So in SJF, the process which requires the least CPU time is given priority. Okay, just like the doctor choosing the patient who can be treated the fastest. So SJF reduces the average waiting time for everyone. Okay, and in non-primitive SJF, once a process starts execution, it cannot be stopped until it finishes. Okay, this is like saying once the doctor starts treatment, they cannot leave the patient in between. And in preemptive SJF, also called like shortest remaining time, here if a new process arrives with a smaller burst time than the currently running process, so the CPU is taken away and given to the new one. Okay, so this is like a doctor leaving a long treatment midway. If a if suddenly a patient arrives who can be treated in just 5 minutes. Okay, so in real operating systems, preemptive scheduling is more practical. Okay, but for like simplicity we will start with non-preemptive. Okay, see, working principle. Always pick the process that needs the least CPU time from the ready queue. Example, non-preemptive SJF. Let's consider four processes with arrival time and burst time. See, so basically we have four processes. Process P1 arrives at time 0 with burst time 7. Process P2 arrives at time 2 with burst time 4. Process P3 arrives at time 4 with burst time 1. Process P4 arrives at time 5 with burst time 4. Okay, now let's see how they will execute step by step. Okay, so at time 0 only P1 is available, so it will start first and run from 0 to 7. Okay, okay, then by the time P1 finishes, so all the other processes have already arrived, P2, P3 and P4. Okay, so out of this P3 has the shortest burst time, just 1 unit, so it executes next from 7 to 8. Okay, and now P2 and P4 are left, so both with burst time 4. Since both are equal, we choose the one that arrived earlier. That means P2 will execute from 8 to 12. Okay, so finally P4 executes from 12 to 16. Okay, so the execution order is P1, then P3, then P2, then P4. Okay, see, now let's calculate the important terms here. First one is completion time. So completion time means the time when a process finishes execution. Okay, for P1 it is 7. For P2, sorry, for P3 it is 8. Okay, 8. For P2 it is 12. Okay, for P4 it is 16. Then turnaround time. So basically the total time from arrival to completion. For P1 it is 7 minus 0 means 7. Okay, then for P2 it is 12 minus 2 means 10. Then for P3 it is 8 minus 4 means 4. For P3 it is 16 minus 5 means 11. Okay, then waiting time. Waiting time means the time a process spends waiting in the ready queue. Okay, so P1 7 minus 7 0. For P2 10 minus 4 6. For P3 4 minus 1 3. And for P4 11 minus 4 7. Okay, so finally P1 process P1 has completion time 7 and turnaround time 7, waiting time 0. And process P2 has completion time 12, turnaround time 10 and waiting time is 6. For process P3 has completion time is 8, turnaround time 4, waiting time 3. And the last is process P4 has completion time is 16, turnaround time 11, and waiting time is 7. Okay, see, if you notice, the shorter jobs get completed quickly, which reduces the overall waiting time of the system. Okay, so that is the biggest advantages of SJF. Okay, but like it also has a problem. Okay, in SJF, so it is very difficult to predict the exact burst time of a process in advance. Okay, so sometimes longer process may starve if short jobs keep coming. Okay, so like SJF is a very efficient algorithm, but it is not always like practical in real systems. Okay, so basically, um, SJF selects the process with the smaller burst time first, and it reduces the average waiting time compared to FCFS. Okay, and it has two types, non-preemptive and preemptive. Okay, and it suffers from prediction problems and starvation. Okay, basically, mm, SJF have some advantages. Very efficient in reducing average waiting time, provides better turnaround time for smaller processes, and the disadvantages is it requires us to know the burst time in advance, which is not always possible in real systems, and the long processes may suffer from starvation because like short processes keep getting priority. Okay, so this is why in a real operating system SJF is often combined with other techniques like agile or use in its primitive version. Okay, thank you.